So here now we will start with discussing corona discharge. Corona you might have observed in rainy season, humid atmosphere. When there is a bluish sheet surrounding that corona transmission line, then that discharge occurs. And corona discharge occurs in non-uniform field. Okay. So let us start that. So let us watch this video, or you from this lecture or from this screen, what you can tell me about this? What is this? Have you observed this phenomenon, students?
This
Students,
extraordinary
have you
form of
observed
lightning.
this?
This is the first time that mankind has seen upward lightning in such detail as we're
Have
seeing
you
right now,
observed this,
and our
students?
understanding of physics.
Students, you could see video or no? Students, you could see video or no?
Yes, yes,
So
ma'am.
what is that? What is that? We just say it is a lightning, okay? We say lightning, thunder, and you have to learn this now, lightning and thunder, how lightning occurs, how that happens. That is nothing but a discharge from the sky to the ground, and that goes return also from ground to the sky, because see, video title was amazing upward lightning. Upward lightning means lightning goes from ground to sky also and sky to ground also, and whole this phenomenon we have to learn, okay? But before learning that phenomenon, in another chapter, one complete chapter is there, low voltage and lightning phenomenon, and then different theories we have to discuss according to Townsend theory. Again, that will require to understand uniform field, Townsend theory, streamer theory. So today's part of the session is very important to understand how corona discharge occurs. I told you corona discharge occurs in non-uniform field, and you have learned little bit about the corona discharge in power system. What is that corona discharge? As a power loss, not the corona which is happening now in COVID situation. Okay. So corona discharge is also known as corona effect, and it is the discharge caused by the ionization of the air. Ionization of the fluid. Why it is said fluid? Because air will become damp in that. Humidity will be very large. And when humidity will be very large, then generally corona occurs in the air. But it happens in the our devices also, and power loss will also take place. So we have to learn that. So that is nothing but the ionization of the air surrounding conductor. Okay, surrounding conductor, that is electrically charged. When you see that corona surrounding the transmission line, the transmission line is a conductor, and between the two transmission line is the air, and that air will become ionized surrounding that. And when that will become ionized, then we say corona. Then what is the difference between corona and full breakdown or ionization? When we see two electrodes, that phenomenon completes from one electrode to the another electrode. But here only surrounding some portion of the conductor, you will observe some ionization, some illumination effect, bluish sheet glow surrounding conductor, and therefore that corona is nothing but the partial discharge, not a complete discharge. Okay, so today we have to learn that corona discharge. So corona effect will occur in high voltage system unless sufficient care is taken to limit the strength of surrounding dielectric field. Corona phenomenon is very important to have insulation coordination, to decide protection degree, and also protect from the faults. To understand this, you have to see first what is uniform field and non-uniform fields. So you have learned that corona discharge will occur with the hissing sound, cracking noise, and in before breakdown also you might have observed in liquid also that hissing sound comes. So when high voltage electric power transmission line you will see in rainy season, you might see violet glow, glow. That is nothing but the production of ozone. Ozone gas is produced due to the ionization. You might have just smell, burning smell also. in some while operating some switches or devices. Burning smell, that is nothing but due to the ozone gas. And ions have also smell. You have seen primary electrons liberate means that is ion. Secondary electrons liberate, that is also ion. Positive ion remains from the gas molecule, that is also ion. So they have some peculiar smell also, and due to that ozone gas is also created surrounding the conductor, and it may cause radio interference and power loss. So this part of corona you have discussed or seen in previous power system. So type of discharge characteristic of sharply non-uniform field. So corona will occur when uniform field, and that is also sharp non-uniform field will be there. Generally, what are the examples of non-uniform field? Point plane gap. So one electrode is point or rod shape and another electrode is plane. Plane means plate. Okay, so here to understand this whole discharge, we first discuss what is this non-uniform gap, what will be electric field intensity. So corona will generally happen in sharply non-uniform field, point plane gap or wire cylinder gap because one conductor may be wire just like a transmission line. One conductor it might be wire and second might be rod or might be cylinder. So that gap is called as wire cylinder gap or point plane gap. Okay. So breakdown strength when it will become higher than 30 kilovolt per centimeter. Generally, we say that ionization of air will occur at 30 kilovolt. Means when gap between electrode is 1 centimeter, then ionization potential will require, breakdown will require 30 kilovolt. So air withstands this 30 kilovolt per centimeter. But if you at 20 degree, because pressure and temperature affects on breakdown voltage. So at room temperature you can see atmospheric pressure and 20 degrees Celsius temperature. Approximately we say that breakdown strength is 30 kilovolt per centimeter for air. Okay. But now when this voltage surrounding the electrode will become higher than 30 kilovolt per centimeter, definitely air surrounding electrode will be ionized. The gas in the immediate vicinity of high stressed electrode breakdowns and a luminous glow appears. Now, the gas means air surrounding the high stressed electrode in plate or in Townsend theory of breakdown. We have just observed what happens from cathode to anode, and whole electrode gap will be breached with electrons. But when we say corona, that will be only ionization surrounding one electrode surface. And which is that one electrode surface whose electric field intensity will be very high? Near that electrode, air will break down and luminous glow will appear. Breakdown will not take place, but ionization, partial discharge will take place. Means corona discharge will take place. So the color of glow discharge is generally observed as bluish luminescence. But you might have just studied positive corona, negative corona. Positive corona is bluish white sheet and negative corona is radish spot. Here also in HV we have to learn much more about corona, positive corona, negative corona, comparison between uniform field, non-uniform field, between streamer theory and between this Townsend's theory, between uniform field and non-uniform field, which is very important for oral also and for practical experience also. So the phenomenon of local breakdown is called as corona. Okay. Local breakdown. See, word only tells that it is not complete between the two electrode. Word local indicates that only near to one electrode. Partial gap, not complete gap. Some region in the gap means local and breakdown. So don't confuse between local breakdown and complete breakdown, or rather you say discharge, okay, which is called as corona. So corona is always accompanied by hissing sound, ozone, and current pulses, because current will be not smoothly flowing, because we have seen current growth equation, Townsend breakdown criterion. But here in corona discharge, current will be in form of pulses, means it will be not uniformly flowing. Okay, and time of the order will be 10 microsecond. One current pulse will last 10 microsecond, and that it will disappear. Again second pulse again, means what is happening. In another word, I can tell you, current pulses means what? Ionization finished, ionization immediately, that ionization will cease, again ionization, again ceasing, like that. So current will be only lasting for small time, 10 microseconds. And corona is a form of high pressure glow discharge. Formation of corona does not mean full loss of insulating properties by the gaseous phase, because it will not break down from one electrode to the another electrode, and therefore it will not have some complete loss but partial loss, power loss. So formation of corona discharge in insulation is not desirable. This is not desirable phenomenon. Corona should not occur. Power loss is there. So what are the reasons that corona loss is not desirable? Because it will deteriorate the insulation and its ultimate failure. Generally, it occurs in the voids or blockings of air in solid and liquid insulating material. Also, this will occur. And in transmission line or in air, you have observed that. You might have observed. So, just now I have shown you in video also, that is due to the ionization only. But that is different phenomenon, lightning phenomenon. So, it gives damages to the insulation. Because see, when corona will appear between the two transmission line, that transmission line has to bear high loss, hissing sound, ozone. So deterioration of conductor surface, that transmission line surface will take place, and therefore insulation. What is the, if it will happen in the our devices like transformer or some machines, then it will deteriorate the insulation, because in transmission line air will deteriorate, but that will be occupied with the fresh another air. So, if it happens in our devices, then we are not going to replace insulation immediately. So, day by day, if corona will persist for 1 year, 2 years, means will be happening sometimes, occasionally, that will deteriorate insulation and final failure will take place. So, corona causes power loss, because I square R loss, you know that power loss will be taking place, and it will exceed the load losses. It is one of the power loss. So, load losses or loss in power system or in that devices will also enhance. And due to this high power loss, it will cause electromagnetic radiations also, and radio interference also, due to the pulse nature of corona. Okay. Now, before discussing how that phenomenon occurs, I would like to make you understand what is meant by electric field intensity in uniform field and in non-uniform field. So here we are discussing this Townsend theory between the plate electrode. We just took example of plate electrode. So if you see plate electrode, lines of flux will be like this, and it will be starting from positive to the negative. Actually, I just forgot today's my pen. Uh, so this will be positive and this will be negative. So it will be no, it will be originate from negative to positive. Okay, so lines of flux will be like this. But what we mean to say here, when one line of flux will start from electrode, it will go to the another electrode. This will go, it will start, it will go like this. But if you see radical distance, perpendicular distance will be very same, because I told you what is E. I told you E is V by D, is V by D. And what is this V? V is the applied voltage across the gap. So try to remember this E and just start drawing the diagrams. Okay. So this is the V. And then what is this perpendicular distance? This distance we have to consider. Perpendicular distance. Okay. This perpendicular distance. So perpendicular distance is here 4 centimeter. Here is also 4 centimeter. Here is also 4 centimeter. I have explained this in previous lecture. Okay. So that way you can just see perpendicular distance is same for everywhere in the plate electrode. So this is uniform field. We say this is the uniform field. So you just find out electric field intensity in this gap. E is equal to V by D. If we are given 30 kilovolt, 30 kilovolt, what will be electric field intensity on the electrode? 30 divided by 4 centimeter. Here 30 by 4 centimeter, here also 30 by 4 centimeter, here also 30 by 4 centimeter. So electric field intensity will be uniform on the electrode surface, in the gap, on the cathode, on the anode, everywhere. Okay. Now what about sphere electrode? If you'll consider sphere electrode, then see how lines will start from this sphere to this. So here also it seems uniform, more uniform. This distance is same, but you can just see here what is happening. Lines of flux are crowding on the sphere surface. Okay. So this figure I have just cut it from another diagram. So just try to make you understand, but this is different. Okay. So these electrodes are somewhat smaller than this, but you see here when electrode surface diameter and the gap distance is very less in comparative with the sphere electrode, you will see this picture. But if diameters are small and distance is too much, then you will just see somewhere you will just see crowding effect. And here you can see radical distance, perpendicular distance is very small, 1 centimeter. Here 1 centimeter. Here suppose 2 centimeter and here 3 centimeter. So sphere electrodes are examples of uniform field as well as non-uniform field. When S by D ratio is somewhat, means gap distance is comparable with the sphere diameter, it gives uniform field. But if the gap distance is too much as compared to diameter, means S by D ratio, here D is small and separation is large. So S by D is greater. If S by D ratio is greater, then sphere electrode gives non-uniform field. Okay. Now you have to just think what will be lines of flux. Here it is shown from positive to negative. Okay. From positive to negative, they will start originating. Okay. So you must able to draw these lines of flux and then just plot the variation of electric field intensity. So I will give you, think it on your paper, take pen and just paper and draw two spheres and start drawing lines of flux. Then take example of rod, then take example of rod plane, and here I have shown this the difference. Here diameter and separation. So S by D ratio. Now here diameters are more and separation is something comparable with that diameter. So you can just say S by D ratio is diameters are less, so S by D ratio is 0.6. 0.6 you have to consider, okay, for comparing. For S by D ratio is less than 0.6 or greater than 0.6. And here you can just see distance is large. So draw the lines of flux. Here also draw the lines of flux. Here also draw the lines of flux because we have to see this corona between point plane gap, between rod gap, and when uniform field. This is also non-uniform field. Experiment is also there. You must able to draw lines of flux. You must able to draw electric field intensity variation. Okay, 2 minutes you take and just start think to draw. Then I will just explain. Actually, I don't have pen, but in morning I draw it on paper and I have just pasted figure. Okay. So here I am telling you. Now you can just see this is rod plane gap. Okay. So this is rod and this is plane or plate electrode. One electrode is rod shape and another electrode is plate shape. And now lines of flux will be starting from this point. It will go to this. It will go to this. It will go to this. And then again I can tell you more lines will be like this. More lines will be like this. Now, if we have to plot variation of electric field intensity on y-axis and gap distance on x-axis. So, here gap distance is on x-axis and electric field intensity on the y-axis. Now, here see gap distance means first care you have to plot extension of this gap. What is the gap here? Exactly this point you have to take and here this across the electrode surface. So, extend this dot in many books and means not in many books one diagram you will be getting this but they are not showing properly. So here you must take care that gap distance should be exactly extended below the electrode surface. Okay. Now What will be electric field intensity at this point? Electric field intensity at this point will be voltage applied across this gap, suppose 30 kilo, divided by perpendicular distance, radius of curvature of the electrode. Now, what is the radius of curvature of this electrode? Suppose 1 mm. So, what will be electric field intensity here? 30 divided by 1 mm. Now, you convert that 1 mm into centimeter. Okay, that will be 10 raised to minus 1. So, electric field intensity will be 300. 30 divided by 10 raised to minus 1. The 10 raised to minus 1 will come in the numerator. Okay. So, that will become 10 raised to 1. So, you will just see electric field intensity here will be very high. So, here at this point is taken. Electric field intensity is very high. Now, as you approach towards the plate, you can see perpendicular distance of the lines of flux goes on increasing. Here, suppose 4 centimeter. Here it is suppose 4 mm, then 1 centimeter, then 2 centimeter, and here it is maximum, okay, 3 centimeter. So you can just see, and what will be here? Lines of flux will come up to the electrode surface. So here it will be divided by 5, 30 divided by 5, okay. So only 6. So electric field intensity across this will be only 6. So you must be able to draw this in the oral exam and also explaining it. Okay. So learn this drawing electric field intensity variations, lines of flux also. And if you will understand what is the happening of electric field intensity, then next question to understand how corona happen. Okay. And what will be corona when rod is positive? Suppose here point is positive and this electrode is negative, different phenomenon will happen. Okay. And when rod is negative and this is positive, again different. When rod is positive, again different. So you have to understand, when rod is positive what happens, when rod is negative what happens. You must be able to compare between rod positive and rod negative. And you might have heard positive corona, negative corona. So to extend that positive corona, negative corona, we have to consider rod is positive, then that will be positive corona. And when we'll say rod is negative, we'll say negative corona. Okay. So then after that, we'll start steamer theory. Now, electric field intensity variation will be very much varying in this point plane. So you just see very maximum on the rod and very less on the plate. So electric field intensity vary too much here. So this example is the strongly varying non-uniform field. Okay. In uniform field and non-uniform field, in non-uniform field, strongly varying non-uniform field and weakly varying non-uniform field are there. So strongly varying means too much variation. If slight variation, you can say weakly varying. Okay. So here this is the part. Now once you will understand this, you can tell me electric field intensity at the rod is very high. And what will happen surrounding air to this? And I told you ionization potential of air is 30 kilovolt. So here is more than 30 kilovolt. So fatak this ionization will happen here. Only primary ionization will happen here. Electrons will be escaped fully in this gap. I don't know what will happen through this gap. But this portion, whatever we have studied primary ionization, number of electrons we will see here. And then electron will start rushing towards the gap. But if you will see, full air surrounding this point will be ionized. And that is called as partial discharge. And then positive remnant things from that gas molecule will just bombard on this electrode surface, because intensity is very large. So fastly they will attract on this electrode. Again electrode will liberate secondary electrons, and you will see within a fraction of second breakdown will take place. So I told you, if suppose gap distance is 5 centimeter and breakdown voltage is suppose 100 kilo for that gap, then for non-uniform gap, even if gap distance is same, you may get breakdown voltage as 10 kilovolt or 15 kilovolt, because even if voltage applied is 10 kilovolt, electric field intensity will be very high. That is the things, means don't see voltage, see what is the electric field intensity. and therefore it is very dangerous. Non-uniform field are very dangerous because breakdown of non-uniform field will be very small, because you can just see if it would have been plate, then phenomenon would have developed slowly, evenly in the gap. But here ionization occurs very fast because electric field intensity becomes 10 times more. I told you the example. So immediately breakdown will take place, because once here we will get many electrons. Now our initiating electron now will be not only one, it will be very large, and they will just have collisions between more gas molecules, and that process will just continue in the gap. Okay, now here it is explained. So these are the lines of flux between the point. Here this is rod and here it is point. Point electrode. So what is the difference between rod and point? Point means just like needle, and rod means at least you will get surface here. But when you will see needle electrode or point electrode, again this variation in electric field will be more strong than this rod plane. So usually examiner asks where breakdown will take place, in point plane or rod plane, or if gap distance or other conditions remaining same. So here you can just see very fast ionization will take place. Breakdown of this you will get very less. But now we are not discussing breakdown, we are discussing corona discharge. So ionization surrounding this tip will be very fast. So here you can say this is shown as ionization region, and this ion flow direction. So ion flow will definitely come towards the positive plate. And this is the drift region, because see, when electron will be liberated here due to primary ionization, it will be drifted towards positive, but not with very high force, because here intensity is less as compared to here. Okay, so this is called as drifting region. If you see, this drifting region is very large, and this region is very less, but it will cause the ionization, and this is your applied voltage V. So okay, now, to corona discharge, you have to explain when rod is negative and when rod is positive. And I told you, when rod is negative, we have to see primary ionization will take place near the rod. When rod is positive, again primary ionization will take place near the rod. You just see, you apply Townsend's theory when rod is positive, when rod is negative, to understand second lecture. This is what we have to discuss. Okay, I have to just tell you, we have to understand what happens with rod negative and when rod positive. So in detail we will discuss, and when we will discuss this, then we'll go to the streamer theory. So this is just, you can see that here trichel pulses, corona will be happening in form of pulses, trichel pulses, and this will be very fast without pulses, and when spark occurs it will be ionization bridging complete two gap. So you might have observed this spark or breakdown. Okay, so this we have to understand. This is positive corona. Here it is shown positive corona, how it will happen like this, and negative corona, how it will happen like this. We have to discuss in detail. So before that, just I have drawn in various gap. Try to understand this. So I have just shown you rod and plate. So rod, you can just see lines of flux will be like this, and then you can see at this tip electric field intensity will be very large. But here you can just see lines of flux will come up to this surface. So here distance, radical distance of the electrode is large, and here radical distance is very small. So at this tip I have shown this electric field intensity peak. So this will be variation, okay, near below electrode. Now slowly radius perpendicular distance is going increasing. So you can just see, and at this plate it will be very large distance. So I have shown it here minimum. So intensity will vary like this. Okay. So this is intensity, maximum intensity, which will be exactly at the rod surface tip, and then some average intensity will be here, because if minimum is this and maximum is this, average will come somewhere like this. So E average will be different than maximum field. Minimum field is also there. So this is strongly varying field. Now here I have shown rod. Okay. So when rod is there, then again at this tip it will be maximum. Again at this tip it will be maximum. But here on the electrode surface it will go on reducing. Okay. And then see E average will be here, E minimum is here, and E. But here in rod as these two shapes are same, more over portion will be uniform. So you can just see this portion will be uniform. So I have shown this, it's uniform. So this is somewhat weakly varying field as compared to rod plane. So these lines of flux you need to draw it. Now sphere I have shown you here. So when sphere electrode gap distance is less, it is uniform. So this is electric field intensity. So everywhere this perpendicular distance is same. So uniform. But when now that S by D ratio is, you can just say separation is higher than diameter. So it is higher. So it is example of non-uniform field. See, because lines of flux here they will crowd. So here it will be maximum, and here on this electrode surface it will be, and small variations will be there here. Okay, so same sphere is example of uniform field and non-uniform field. Okay, so here I got some pictures on internet, so I tried to show you. So see when rod is positive, rod here lines are shown here. Okay, so this lines of flux you can consider it is sphere rod. And here also you can just see when this is more lines of flux. So it will depend upon what is voltage applied. And here you can just see in plate electrode. Okay. Now we have to see difference between uniform field and non-uniform field. Before that, we'll discuss how breakdown will take place in non-uniform field or corona discharge, or you can understand this uniform field and non-uniform field. We will see in next lecture. Okay.